This is Ayan from PDA College of Engineering, Computer Science Department. I am here to present the seminar on the data mining application. So first of all, let's look at the introduction of the data mining application. First, data is a set of discrete objective facts about an event or a process that have little use by themselves unless converted into information. We have been collecting numerous data from simple numerical measurements and text documents to more complex information such as spatial data, multimedia channels, and hypertext documents. Next, nowadays large quantities of data are being accumulated. The amount of data collected is said to be most doubled every year. As extracting data or seeking knowledge from the massive data mining techniques are used. Data mining is used in almost all places where a large amount of data is stored and processed. For example, banks typically we use data mining to find out their prospective customers who could be interested in credit cards, personal loan, or insurance as well. Since banks have the transaction details and detailed profile of their customer, they analyze all this data and try to find out patterns that help them to predict that certain customers would be interested in personal loans, etc. So basically the motive behind mining data, whether commercial or scientific, is the same. The need to find useful information in data to enable better decision making or a better understanding of the world around us. So here are the common data mining application domains which are categorized. First, financial data analysis, retail telecommunication industries, science and engineering, intrusion detection and prevention, recommender system. Here, as you can see in the figure, they are categorized under a given circumstances. So let's look one by one. At first, data mining for financial data analytics. Here, it is categorized into four different parts. First, design and construction of data warehouse for multidimensional data analysis and data mining. In this, like many other applications, data warehouse need to be constructed for banking and financial data. Multidimensional data analysis method should be used to analyze the general properties of such data. For example, a company financial officer may want to view the debt and revenue changes by the month, region and sector and other factors along with the maximum and minimum total average trend, deviation and other statistical information. Next, loan payment prediction and customer credit policy analysis. In this, loan payment prediction and customer credit analysis are critical to the business of the bank. Many factors can strongly or weakly influence loan payment performance and customer credit rating. Next, classification and clustering of customers for targeted marketing. Classification and clustering methods can be used for customer group identification and targeted marketing. For example, we can use classification to identify the most crucial factor that may influence a customer's decision regarding banking. Customers with similar behavior regarding loan payments may be identified by the multidimensional clustering techniques. Next, detection of money laundering and other financial crime. To detect money laundering and other financial crime, it is important to integrate information from multiple heterogeneous databases. For example, bank transaction database and federal or state crime history database, as long as they are potentially related to the study. Multiple data analysis tools can be used to detect unusual patterns such as large amount of cash flow at certain periods by certain group of customers. So the next factor is data mining for retail and communication industries. In this, it is categorized into 6 equal factors. First, let us see one by one. Design and construction of data warehouse. Because retail data cover a wide spectrum, there can be many ways to design a data warehouse for this industry. The levels of detail to include can vary substantially. Next, multidimensional analysis of sale, customer product, and time and region. The retail industry requires timely information regarding customers, needy product, sales, trends, and the fashion, as well as the quality cost, profits, and services commodities. It is therefore important to provide powerful multidimensional analysis and visualization tools. Next, analysis of the effective sales campaign. The retail industry conducts sale campaigns using advertisements, coupons, and various kinds of discounts. And effectiveness of the sale campaigns can also improve the company profits. Next, customer retention analysis of customer loyalty. We can use customer loyalty card information to register sequence of purchases of particular customers. Customers' loyalty and purchase trends can be analyzed systematically. Goods purchased at different periods by the same customers can be grouped into sequence. Sequential patterns mining can be used to investigate changes in customer consumption or loyalty and suggest adjustments on the pricing and variety of goods and help to retain customers and attract new ones. And the next, product recommendation and cross referencing of items. By mining associations from sales records, we may discover that the customer buys a digital camera is likely to buy another set of items. Such information can be used to form product recommendation. Next, fraudulent analysis and the identification of unusual patterns. Fraudulent activities cost the retail industry millions of dollars per year. It's important to identify potentially fraudulent users and their atypical usage patterns. Second, detect attempts to again fraudulent entry or unauthorized access to individual or organized accounts. And the next, discover unusual patterns. They may need special attention. And next, we can see the data mining in science and engineering, which is categorized into four equal factors: data warehouse and type of pre-processing. Data pre-processing and data warehouse are critical for information exchange and data mining. Creative warehouse often requires finding means for resolving inconsistent or incompatible data collected in multiple environments and a different time period. Next, mining complex data types. Scientific data sets are heterogeneous in nature. They typically involve semi-constructed and unstructured data, such as multimedia data and georeferenced stream data, as well as data with sophisticated, deeply hidden semantics. Robust and dedicated analysis methods are needed for handling spectral data, biological data related concepts, hierarchies, and complex semantic relationships. Next, graph based and network based mining. It is often difficult or impossible to model several physical phenomena and process due to limitations of existing capture of the spatial topological geometry, biological and other relational characteristics present in scientific data sets. Data mining in engineering shares many similarities with the data mining in science. Both practices often collect massive amount of data and record data preprocessing, data warehousing, and scalable mining of complex types of data. Data mining in computer science can be used to help monitor systems status, improve system performance, isolate software bugs, detect software plagiarism, software analyze software fraudulence, and network illustration. The next, data mining for iteration detection and prevention, which is the majority of iteration detection prevention system use a signature based detection or anomaly detection. Signature based detection, this method of detection utilizes signatures which are attack patterns that are pre-configured and predetermined by domain experts. A signature based intrusion prevents system monitors the network traffic for the matches or to the signatures. The next, anomaly based detection. This method builds models of normal network behavior that are then used to detect new patterns that significantly deviate from the profile. Such deviation may represent actual intrusions or simply by new behavior the need to be added to this profile. The main advantage of anomaly detection is that it may detect novel intrusions that have yet to be observed. Typically, a human analyst must sort through the deviations to ascertain which represent real intrusions. Next, data mining methods can help an intrusion detection and prevention system to enhance its performance in various ways. First, new data mining algorithms for intrusion detection. Data mining algorithms can be used for both significant based and anomaly based detection. In signature based detection, training data are labeled as their normal or intrusion. A classifier can then be derived to detect known intrusion. Anomaly based detection builds models of normal behavior and automatically detects significantly deviation from it. Methods include the application of clustering, outliers analysis, and classification algorithms and statistical approaches. Next, association, correlation, and discriminative patterns. Analyzers help select and build discriminative classifiers. Association, correlation, and descriptive patterns mining can be applied to find relationship between system attribute describing the network data. Such information can be provided insight regarding the selection of useful attributes for intrusion detection. And the next, analysis of stream data. Due to transient and dynamic nature of intrusions and malicious attacks, it is crucial to perform intrusion detection in a data stream environment. Moreover, an event may be normal on its own, but consider malicious if viewed as a part of sequence of events. Next, distributed data mining. Intrusion can be launched from several different locations or targeted to many different destinations. Distributed data mining methods can be used to analyze network data from several networks locations to detect this distributed attack. Next, visualizing and querying tools. Visualizing tools should be available for viewing any anomalous patterns detected. Such tools may include featuring of viewing, association, discriminative patterns, clusters, and outliers. Intrusion detection system should also have geographical user interface that allows security analysis to pose queries regarding the network data and intrusion detection goals. Next, data mining and recommender system. Today's consumers are faced with millions of goods and services while shopping online. Recommender systems helps consumer by making product recommendations that are likely to be interest to the user, such as books, CDs, movies, restaurants, online new articles, and other services. Recommender systems may be either a content-based approach, a collaborative approach, or a hybrid approach that combines both content-based and collaborative methods. The current based the content based approach recommends itself it items that are similar to items that use preferred or queried in the past. It relies on product features and textual item descriptions. The collaborative approach may consider a user social environment. It recommends items based on the opinions of other customers who have similar taste or preferences as a user. Recommender systems use a broad range of techniques from information retrieval, statistic machine learning, and data mining to search of similarities among items and customer preference. Thank you.